Welcome to today's ArXiv CS Digest for April 28th, 2026. We received 666 new computer science papers today across 64 subfields. Let's dive into top picks. Trend 1 of 5, Real-Time Vision and Behavior Analysis. These papers explore real-time analysis of visual and behavioral data for intelligent systems and applications. This cluster covers 85 papers. Representative work includes No Pedestrian Left Behind, real-time detection and tracking of vulnerable road users for adaptive traffic signal control, privileged foresight distillation, zero-cost future correction for world action models, and Fringe GUI, a graphical user interface for data collection and visualization of vaping behavior from a passive vaping monitor. Trend 2 of 5, AI Agents for Data and Speech. These papers explore AI agents that understand, generate, and interact with data and speech for diverse applications. This cluster covers 142 papers. Representative work includes DV World, benchmarking data visualization agents in real-world scenarios, robust deepfake detection, mitigating spatial attention drift via calibrated complementary ensembles, and Audio 2 tool. Speak Call Act, a dataset for benchmarking speech tool use. Trend 3 of 5, AI for Code and Language. This trend explores AI's role in understanding, generating, and optimizing code in natural language. This cluster covers 183 papers. Representative work includes DockSmith, scaling reliable coding environments via an Agentic Docker builder, make any collection navigable, methods for constructing and evaluating hypergraph of text, and a paradox of AI fluency. Trend 4 of 5, AI learning and uncertainty. This trend explores how AI models learn, adapt, and perform reliably amidst uncertainty and imperfect information. This cluster covers 131 papers. Representative work includes how fast should a model commit to supervision, training reasoning models on the Thales-Loss continuum, teacher forcing as generalized Bayes, optimization geometry mismatch in switching surrogates for chaotic dynamics, and Tietz affinity, similarity-driven parameter reuse for continual offline reinforcement learning. Trend 5 of 5, AI systems and verification. Formal methods and verification techniques are increasingly applied to complex AI systems and their underlying components. This cluster covers 125 papers. Representative work includes recursive multi-agent systems, remote concolic multiverse debugging, extended version with additional appendices, and credit limits beyond full collateralization in decentralized micropayments, incentive conditions. Up next, our first paper out of 5, DockSmith, scaling reliable coding environments via an agentic Docker builder by Jiaran Zhang and Xiangyu Zhang from StepFun. Let's break down its key contributions. DockSmith is a specialized agentic Docker builder that treats environment construction as a core agentic capability, not just a pre-processing step. DockSmith exercises long-horizon tool use, dependency reasoning, and failure recovery during environment construction, generating valuable supervision. DockSmith achieves state-of-the-art performance on multi-Docker eval and demonstrates improved out-of-distribution performance on other benchmarks, showcasing broader agentic benefits. Up next, our second paper out of 5, AInstein, Can LLMs Solve Research Problems from Parametric Memory Alone? By Shambhavi Mishra and Christopher Pal from Livia, ETS Montreal. Let's break down its key contributions. Introduces AInstein, a framework to test LLM reasoning by solving AI research problems using only parametric knowledge, without external aids. Employs iterative critique loops, mimicking scientific inquiry, where specialized solver agents propose and refine technical solutions. Conducts a large-scale evaluation on 1,214 ICLR papers using an LLM as a judge paradigm, assessing success, rediscovery, and novelty of LLM-generated solutions. Up next, our third paper out of 5, The Thinking Pixel, Recursive Sparse Reasoning in Multimodal Diffusion Latents by Yue Sun and Siyu Zhu from Shanghai Academy of AI for Science. Let's break down its key contributions. Introduces a novel recursive component within joint attention layers to iteratively refine visual tokens over multiple latent steps. This framework efficiently shares parameters through sparse selection of specialized neural modules. A gating network dynamically selects appropriate neural modules at each step, conditioned on visual tokens, diffusion time step, and conditioning information. This allows for adaptive and context-aware refinement of image generation. Demonstrates superior performance in class-conditioned ImageNet image generation and other benchmarks, addressing the limitations of conventional diffusion models in complex, structured reasoning for multimodal tasks. Up next, our fourth paper out of 5, Expander Decomposition with Almost Optimal Overhead by Nickel Bunsell and Thatchafal Saranarak from University of Michigan. Let's break down its key contributions. Introduces the first polynomial time algorithm for computing a near-optimal flow expander decomposition, removing $8 \5 log 1 + 1 in dollar fraction of edges. Achieves an overhead of $log 1 + 1 in dollar, which is nearly optimal and significantly better than previous algorithms requiring $0 \5 log 1.5 in $0 \5 log 2 in dollar edge removal. Ensures that each remaining connected component is $8 \5 flow expander, a stronger property than being $8 \5 cut expander. Up next, our fifth paper out of 5, Barriers to Universal Reasoning with Transformers and How to Overcome Them, by Oliver Krauss and Michael Hahn from Saarland University. Let's break down its key contributions. Transformers with chain-of-thought reasoning are limited to $TC$0 expressivity when generalizing to longer sequences if the vocabulary is fixed. This means the theoretical expressivity benefits of COT do not hold under length generalizable learnability. By allowing the vocabulary to grow with problem size, transformers can achieve length generalizable simulation of Turing machines. The COT trace length scales linearly with the simulated runtime. Unique signpost tokens and value change encodings are introduced to overcome barriers like repeated copying and last occurrence retrieval. These mechanisms enable reliable length generalization and empirically improve performance on hard problems. That's all for today's AR14 CS Daily. If you found this helpful, please leave a comment, and subscribe for daily paper summaries. See you tomorrow.